problem 5 of grade 11 geometry, right, referred to as Tan-chord theorem. Right? It talks about, the statement goes like this one, right? The angle between tangent and the chord. In this case, we are referring to this angle. That angle is A1. Is equals to angle subtended by that chord in opposite segment. So it means if you are looking at this diagram there, the angle subtended by the chord, between the chord and angle, is that A1. The chord AD is involved with that angle. So if I'm looking at the angle subtended by that chord in opposite direction, I'm talking about this angle E. So at the end, I need to prove angle A1 equals to E. That's what is my target. Now, how do we prove? Right? So the proof starts like this one. Normally, all our angles, all our theorems, we start constructing radius. So in this diagram, or in this theorem, we will start our work by constructing the diameter from point A. If I see diameter from point A is my construction of the diameter, I will write construct diameter MOA. So the moment I talk about the diameter, it tells me two things. It involves the radius. So in this case, first thing, when I'm talking about the radius OA, I know radius is perpendicular to a tangent. That tangent is BAC. Right. The second thing I know about the diameter, that diameter MOA subtends or creates angle, subtends that angle which is going to be 90 degree. In our case, if I join DM, so it means I'm here now, angle D is equals to 90 degree, angle subtended by the semicircle or diameter. So if I'm going back to the radius perpendicular to the tangent, then I will know that my angle A1 plus angle A2 is going to be 90 degree. What's the reason? Tangent perpendicular to the tangent perpendicular to tangent perpendicular to radius, or radius perpendicular to tangent. Right. On the other side, angle D is already 90. So the other two angles, which are the internal angles of a triangle, which I can refer it to M2, no, that's angle M plus A2 is equals to 90 degree. Angle M plus A2 equals to 90 degree. Now if I see these two equations, on my right hand side, both the equation has a 90 degree. So if the right hand side is equal, therefore I can say my left hand side is also equal, which is A1 plus A2 for the left hand side of the equation, this equation, and M plus A2 for this equation. Right? Both of them, they are 90 degree. So if I change the side of A2, it's going to be negative. So A2 and A2 will get cancelled. So here I am. My A1 equals to M. Where I want A1, I don't want M. If I look at this diagram there, M, I got the relation with A2, which is not my target. My target is A1 with E. So I'm going to find the link between these two angles, which I want, that's the angle E, and the angle which I don't want, that's the angle M. So what is the link between these two is here. Angle M is subtended by the chord DA. The same DA subtends the other angle, which is angle E. So in short, the previous one of the theorem, which says the common chord, in this case, angle M equals to angle E. So I can write, but my angle M equals to angle E. What's the reason? It is a common chord or common arc. And what is that arc? AD. There is it. It is this is AD. Common chord AD. So my angle A1 equals to M and angle M equals to E. If I see that angle M is they both a replacement of one another, so I can say angle A1 equals to angle E. That is what I was looking for. This theorem is going to be maybe 5 or 6 marks. 5 marks in grade 12, 6 marks in grade 11. In grade 12 there will be two theorems asked, one from grade 11, one from grade 12. And this is the most commonly asked the theorem as well. Okay, thank you. That's how we prove the theorem. Okay, I hope you will understand this.